This is David Spears, Civil Engineering Instructor at Texas Tech University, talking about CE 2301 statics. Centroids by composite areas is the problem today. And we've got a green shaded area here with those dimensions. Everything's in millimeters, 45 and 45 along the X direction, and a triangle 60 millimeters tall above the y-x-axis and 75 millimeters below the x-axis. So the find is to find the area of that shape and the coordinates of the centroid. So I like to eyeball these things and just say, well, looks like kind of right about there, I don't know. Let's see how that works out. That's just kind of eyeballing it. Okay, some people would divide this into 3 triangles, but I see 2 triangles and an equilateral triangle, which is nice because I've got this thing, which I'll call area 1, this triangle. And it's an equilateral triangle because it's 45 and 45 either side of point A. And then I've got a nice right triangle right down here that I'd call area 2. And while I'm at it, I want to kind of eyeball in the centroids of the areas, 1/3 from the big corner of this right triangle. And for this equilateral triangle, in the x distance, it's that right along that line bisecting the triangle, and it's 1/3 of its height. So what did I just do? So I'd say it's right about there. Okay, look at my equation sheet and I see that the area of something is the sum of the individual parts and pieces. So I've got area 1, which is this equilateral triangle, and I've got area 2, which is this right triangle oriented kind of like this. Okay, the area, they're both triangles. I've got 1/2 base times height. 1/2, in this case, 1/2 of 60 is the height, and 90 is the base. 45 plus 45, that works out to be 2,700. I've written my units up here. Areas are all millimeters squared. For this right triangle, area 2, I've got 1/2 base times height. That's 1/2 75 times 90. And that's equal to 3375. So it's pretty easy. Just add those 2 numbers up. I get 6075 millimeters to the squared. And so that's the answer for the area. I'll use that also in the other calculations. For my equation sheet, I'm dealing with x bar is equal to the sum of the x tilde ai, x tilde I, ai is divided by the sum of the areas. Y bar is just the same thing, the sum of the y tilde I, ai's, divided by the sum of the areas. So that kind of reminds me of the columns that I need for this table. So I need x tilde for each shape. So x tilde for this triangle number 1 is this distance from the y-axis. That's x tilde 1. And that's just the midpoint of that triangle, so it's 45. So I don't have to really calculate anything. Y tilde for that triangle is this height right here. It's 1/3 of its overall height, so it's 1/3 of 60, or 20. For the, I'll do it in red so you can see it. For the x tilde distance is this distance right here, and from the tip it's 2/3 of its overall width. So it's 2/3 of 90, or 60 millimeters. For y tilde, it lies below the x-axis, so it's going to be a negative number. It's this distance right here, y tilde 2, and that's 1/3 of its height, which is 1/3 of 75, or negative 25. Now I just do the math, multiply these columns times each other to get x tilde a and y tilde a. This column works out to be 121,500. This column is 2,700 times 20, or 54,000. For area 2, it's 3,375 times 60, or 202,500. And for y tilde a, do the math and I get negative 84,375. Now I can add those columns and I get 324,000 for the sum of the x tilde a's, and I get negative 30375 for the sum of the y tilde a's. Therefore, x tilde is just equal to this number, this column, sum, divided by the area. So that's 324. So why do I write 325? Divided by 6075, sum of the areas, and I get 53.33 millimeters. We'll look and make sure that makes sense here in a second. Y tilde is just, y bar is just the sum of the y tilde a's, negative 30375, divided by 6075, is negative 5 millimeters. Just quick check of my units. I've got millimeters cubed on the top and millimeters squared for area. That leaves me with millimeters. So the units check out. I look at what these values mean. X bar is 53.3, so it's just to the right of that 45 millimeter line right there. So that looks pretty close. The y bar is negative 5, so it's just barely below the x-axis, and that looks pretty close. The triangle on the bottom below the x-axis is bigger than the triangle above, so that pulls the centroid a little bit to the right and a little bit down below the x-axis.